Welcome to this video on medians and centroids of triangles. In this video, we will learn about two important concepts in geometry, medians and centroids. A median is a line segment that connects a vertex of a triangle to the midpoint of the opposite side. There are three medians in every triangle and they all intersect at a point called the centroid. The centroid is a special point in a triangle that has many interesting properties. For example, the centroid is the center of mass of the triangle and it is also the point of intersection of the three medians. In this video, we will learn how to find the medians and centroid of a triangle. We will also discuss some of the properties of medians and centroids. So let's get started. Please take a piece of paper, draw a triangle on it and then cut along the lines of the triangle. Name the vertices of the triangle as A, B and C. To create a first median, we need to draw the straight line joining the vertex A to the midpoint of the opposite side BC. So we need to create a midpoint on side BC. To do that, fold vertex B and vertex C together, aligning them and make a crease. Then unfold it. You will notice a small mark where the crease was made. Mark a dot there. Connect this dot with vertex A by drawing a line. This line AD will be your first median. To create a second median, we need to draw a straight line joining the vertex B of a triangle to the midpoint of the opposite side AC. So we need to create a midpoint on the side AC. To do that, fold vertex A and vertex C together, aligning them and make a crease. Then unfold it. You will notice a small mark where the crease was made. Mark a dot there. Connect this dot with the vertex B by drawing a line. This line BE will be your second median. To create the third median, we need to draw a straight line joining the vertex C of a triangle to the midpoint of the opposite side, which is AB. For doing that, we need to create a midpoint on the side AB. To do that, fold vertex A and vertex B together, aligning them and make a crease. Then unfold it. You will notice a small mark where the crease was made. Mark a dot there. Connect this dot with vertex C by drawing a line. This line CF will be your third median. AD, BE and CF are the three medians. All three medians of a triangle pass through the same point and the point of concurrence is called the centroid of the triangle. Now we are going to verify the centroid of a triangle divides each median in the ratio 2:1. The centroid of the triangle is denoted as G. Now let's begin by measuring the length of each median using the scale. AD equals 12 centimeter, BE equals 11.1 centimeter, CF equals 11.7 centimeter. Now we are going to verify the centroid G divides AD in the ratio 2:1. For doing that, we have to measure AG and GD using the scale. AG equals 8 centimeter and GD equals 4 centimeter. We need to find the ratio between them. So AG is to GD, 8 is to 4. So 8 is 2 times 4 is 8. From this we can conclude the ratio of AG is to GD is 2:1. We can also simplify this in another method. We all know that A is to B can also be written as A by B. So AG is to GD can be written as AG by GD. So 8 is to 4 can be written as 8 by 4. When you simplify it, you will get 2:1. Therefore, AG is to GD equals 2:1. So we have verified the centroid G divides the median AD in the ratio 2:1. Now we are going to verify the centroid G divides the median BE in the ratio 2 is to 1. For doing that, measure the length of BG and GE. BG equals 7.4 centimeter, GE equals 3.7 centimeter. Therefore, BG is to GE equals 7.4 is to 3.7. So, 7.4 is 2 times 3.7. From this, we can clearly see that BG is to GE equals 2 is to 1. We can solve the same in another way. So BG is to GE can be written as BG by GE, which equals 7.4 divided by 3.7. When you simplify it, you will get 2 by 1. So BG is to GE equals 2 is to 1. Now we are going to verify the centroid G divides the third median, which is CF, in the ratio 2 is to 1. For doing that, we are going to measure CG and GF. So CG equals 7.8 centimeter and GF equals 3.9 centimeter. So CG is to GF equals 7.8 is to 3.9. So 7.8 is 2 times 3.9. From this we can conclude CG is to GF equals 2 is to 1. We can also express the same in another way. CG is to GF can be written as CG by GF, which equals 7.8 by 3.9. When you simplify it, you will get 2 by 1. So CG is to GF equals 2 is to 1. Along with the median and the centroid, even we can verify the length of the sides when a midpoint is created. When a midpoint D is created on the side BC, the length of BD must be equal to CD. So BD equals 6.4 centimeter and DC equals 6.4 centimeter. When you add it, you will get 12.8 centimeter. So BD plus DC equals BC. 6.4 plus 6.4 equals 12.8 centimeter. When a midpoint E is created on the side AC, the length of AE must be equal to length of EC. So AE equals 7 centimeter, EC equals 7 centimeter, AE plus EC equals AC. So 7 plus 7 equals 14 centimeter. When a midpoint F is created on the side AB, the length of AF must be equal to length of FB. So AF equals FB. AF equals 6.6 centimeter. FB equals 6.6 centimeter. When you add it, you will get 13.2 centimeter. So AB equals 13.2 centimeter. In this video, we have learnt how to draw three medians in a triangle, and the centroid of a triangle divides each median in the ratio 2 is to 1.